Section 3.8, slopes of parallel and perpendicular lines. Slopes of parallel lines. If two non-vertical lines are parallel, their slopes are equal. So if two lines have the same slope, they are parallel. If the slopes of two distinct non-vertical lines are equal, then they are parallel. So this is just saying the same thing. So if our slopes are equal, we have parallel lines. Slopes of perpendicular lines. Perpendicular slopes are opposite reciprocals. So an example of that would be like 1/3 and -3/1. Or 2/3 and -3/2. Things like that. Opposite reciprocals make them perpendicular. So if two non-vertical lines are perpendicular, then the product of their slopes is -1. Well, that's the same thing as saying opposite reciprocals. Here we want to write the equation of a line parallel to y equals -3x minus 5 that contains the point -1, 8. So what we're going to do is we're going to steal the slope from the line they provided. So our slope in this case is -3. And now we're going to use our new point, -8 or -1, 8, and point slope form with our slope here to create the equation of a line. So y minus y1 equals m times x minus x1. And so now we'll just plug in our values. So right now we've got y minus 8 equals -3x plus 1. And we'll just go ahead and leave it in point slope form for now. If they asked us to put it in slope intercept, we know how to do that already. This time they want us to have a line, the equation of a line parallel to y equals -x minus 7, containing the point -5, 3. So we're going to steal the slope again. In this case, it's a -1. So our slope is -1 that we have to use, because parallel means you have the same slope. And then we're going to put it in point slope form. So y minus y1 equals m times x minus x1. So we plug in what we know. We've got y minus 3 equals -1, x plus 5. But they want this one in slope-intercept form, so that means we end up having to distribute our slope. So we'll distribute the -1 throughout. That changes our equation. We've got y minus 3 equals -x minus 5. Then we'll add 3 to both sides, in which case our final answer becomes y equals -x minus 2. Here they want us to write the equation of a line perpendicular to the equation y equals -3x minus 5 and contains the point -3, 7. So that's x1, y1 is x1's -3, y1's x1 is -3, y1 is 7. But this time we're not going to steal the slope from the other line. We're actually going to use it to create the opposite reciprocal. So in order to be perpendicular to -3, our slope actually has to be a positive 1/3, because that's the opposite reciprocal to -3. Now using our slope and our x1, y1 point, we're going to create our equation of a line in point slope form. So that means we've got y minus 7 equals 1/3 x minus a -3, so plus 3. And this is our answer in point slope form. And we're going to leave it like that. This time we are going to find the equation of a line in slope-intercept form that is perpendicular to the line y equals 3x plus 5 and contains the point 6, 2. So this is x1, this is y1. We're going to borrow this slope and find the opposite reciprocal. So our actual slope, in order to be perpendicular, should be a -1/3. We'll put this into point slope form. So when we plug these values in, we've got y minus 2 equals negative 1/3 x minus 2, or x minus 6, sorry. There we go. So that's point slope form, but they want our answer in slope intercept form. So that means we have to distribute our slope. And that changes our equation to y minus 2 equals negative 1/3 x plus 2. Then the last thing we need to do is add 2 to both sides. And our final answer in slope intercept form is y equals negative 1/3 x plus 4. So let's try another problem like that again. So once again, we want to find the equation of a line in slope-intercept form for a line that is perpendicular to the line y equals negative 1/2 x plus 5 that contains the point negative 4, 8. So we're going to borrow the slope from this line, and we're going to change it to the opposite reciprocal. So that's going to be a positive 2 over 1, which is the same thing as just 2. Then we're going to put we're going to fill in our values for point slope form. So we've got y minus y1, which would be 8, equals the slope 2 times x minus x1. So x minus a negative 4 would be like plus 4. There we go. And now we just want to change this into slope intercept form. So we're going to distribute our slope. We're going to get y minus 8 equals 2x plus 8. And our last step, we're going to add 8 to both sides. And we end up with y equals 2x plus 16. In this example, we're looking to see if the lines in the diagram are parallel. There's a couple of ways to do this. You could use the slope formula in both cases. And so let's use the formula for right now, and then I'll show you a quicker way to do this afterwards. So using the formula, you do x1 minus, or y1 minus, or y2 minus y1 over x2 minus x1. So if you've forgotten slope formula, I'll put it here. There we go. y2 minus y1 over x2 minus x1. And so we're going to find the slope of the first line. So this is the first line. And so y2, let's say we've got 2 minus 0 over 3 minus a negative 3, so 3 plus 3. So in this case, your slope is 2 over 6, which is 1/3. Line 2, we'll go negative 1 minus a negative 3, so plus 3, over 5 minus a negative 1, so plus 1. So we've got 2 over 6, which equals 1/3. Well, we should notice that the slopes are equal. So this means the lines are parallel. Here we could do the same thing. We could use the slope formula, or if we wanted to kind of move a little faster, we could just count. Keeping in mind that slope is your rise over run. So we're going to create a fraction for rise over run. So let's look at line 1 here. So to go from this point here to this point here, I'm just going to count. So I'm going to go with my vertical movement first. I'm going down 3 and then right 3. So that's negative 3 over 3, which is negative 1. This is line 2, so I want to go from this point to this point. For that, I'm going to go up 5, and then right 7. So that's 5 over 7. Notice that these are not equal, and they're not reciprocals. So this is actually neither. This is not parallel or perpendicular. We can do the same thing here. So for line 1, going from this point here to this point here. So I'm going to go down 6 and then right 4. So -6 fourths. For the other line, I'll go from here to here, which means I'm actually going up 6, right 9. So up 6, up 6, right 9. In both cases, it'd help if I reduce my fractions. So I've got -3 over 2. This time I've got 2 over 3. I should notice right off the bat, these are just flips of one another. So that means they're flips and they have different signs, so they're opposite reciprocals. And opposite reciprocals tell us that our lines are perpendicular. Determine the equation of a line perpendicular and parallel to the line shown that contains the point 6, -5. So what they want us to do first is find the slope of this line, because that's the thing we have to find first. So going from this point here to this point here, I'm going down, well, they're counting by 2's for every line, so we have to be careful. Going from 3 to -3, so down 6, and then I'm going right 4. So that means my slope, -6 over 4, which is a -3 over 2. So to be parallel, I'm going to use the exact same slope. So I'll set this up in point slope form first. So y minus y1, which would be 5, so -5, so plus 5, equals -3 over 2, x minus 6. So that's my parallel point slope form. And then to simplify it down into slope intercept, I distribute. I've got y equals -3 over 2x. And then plus 4 would be my slope intercept form equation. For perpendicular, I know I need to change the slope, so instead of using -3 over 2, I'm going to use a positive 2/3. So when I set up my equation, I've got y plus 5 equals 2/3 x minus 6. Then I'll distribute my slope and bring over the 5, and my slope-intercept form equation becomes y equals 2/3 x minus 9. Wait, hold on 1 second. Minus 9, yep. Okay, there we go. So -2/3 x minus 9. And so we have our equation using the same slope as the line they provided. We have one that's going to be parallel to it, and one that'll be perpendicular to it. Here we want to rewrite the equations in slope-intercept form, if necessary, so it might not be necessary. Then determine whether the lines are parallel or perpendicular and explain how we know. So in part A, this one is already written perfectly, so we're going to leave it alone. But the second equation, we're going to have to move the x away. and then we'll divide by -2. All right, and so now we have our two equations. Notice here that the slopes of 1 and 1/2 are not opposite reciprocals and they're not equal. So this is not parallel or perpendicular. Right. And we'll do the same thing in part B. We have to rewrite both of these equations. So for the first one, I'll move over the 6x, so 2y equals -6x plus 18. Then I'll divide by 2, y equals -3x plus 9. So there's one equation. Then the other equation, I'll do the same thing. We'll go ahead and move over the 12x. So 4y equals -12x plus 24. Divide by 4, y equals -3x plus 6. In this case, the two lines have the same slope, so that means they're parallel.